Next problem, number 47. So the center of mass of an empty 1,250 kilogram car is 2.4 meters behind the front of the car. How far from the front of the car will the center of mass be when 2 people sit in the front seat, 2.8 meters from the front, and 3 people sit in the back seat, 3.9 meters from the front? Assume each person has a mass of 65 kilograms. So this is quite a bit more complicated than the previous problem. This is not particles, and it's not really one-dimensional like the previous problem, particles along a straight line. However, we can model it like that previous problem. So I'm going to draw this as if all of our objects are point masses, particles, along the x-axis. We're going to ignore the y component of this object, and we're going to ignore the z component of this object. This is going to be the front of the car here. And I'm considering positive x to be to the left, just so that everything lines up to the front of the car. So let's make this 1, 2, 3, 4 meters from the front of the car. My scale is not great, but it is what it is. So the center of mass of the empty car is 2.4 meters behind the front of the wheel. So I'm going to put a red dot here. This is object 1. And mass 1 is 1,250 kilograms. X1 is 2.4 meters, right? I'm trying to model this so that it looks like the previous problem, even though these are more complicated objects. 2 people sit in the front seat, which is 2.8 meters. Let's make those 2 people. There's mass 2. Mass 2 is 2 people. And the problem tells us that each person has a mass of 65 kilograms. So 2 people have a mass of 130 kilograms. 2 people. And they, x2, are at 2.8 meters from the front. Then we have 3 people that sit 3.9 meters from the front. So I've got a third mass here, which is hopefully obviously blue. That's 3. M3 is 3 people. 65 times 3 is 195. 3 people. And they are at x3 of 3.9. So now I have reduced this complicated object of car, which is comprised of the shell of the car and the engine and the seats and all the cables and all of that, the trunk, whatever. It's now a single dot, right? Its center of mass is it, and it is located at 2.4 meters from the front of the car. I've reduced 2 people with, brains and guts and arms and legs, right? All sorts of different densities and locations of mass to a single dot at x2 equals 2.8 meters. And same story for 3. And now this problem is the same as 46, our previous example problem. I'm looking at the center of mass along the x-axis. I'm going to multiply each mass, 1250, times its location, 2.4, 130, 2.8, and 195, 3.9, right? Each of those, and divide by the mass in total. So 1250 plus 130 plus, oops, I don't know what symbol I just did there, 1250, 130, 195. All right, so 1,575 kilograms. And of course, we're going to expect the center of mass of the system to be closest to the largest, most massive thing. It should be closest to my red dot at 2.4 meters. So calculating each piece, 1250, 2.4, 3,000, 130, 2.8. I'm showing all the steps. It's probably not necessary. This math is not terribly complicated. We're taking an average, 760.5 kilogram meters for the last one. and then I'm dividing by the total mass. All right, and again, we're noticing that kilogram, meter divided by kilogram gives us our position of the center of mass in meters. If we were still in kilogram meters, we would be in trouble. Okay, so I have a position of center of mass of 2.6, let's round to 3 digits, 2.62 meters from the front of the car. So again, not surprisingly, the center of mass of the system lies between 1 and 2. XCM is 2.62 meters.